Welcome to VTU Physics. In this video, we are trying to understand the model profile, that is, modern characterization and instrumentation techniques. This model comes under mechanical branch. So, before we begin with the syllabus, we need to understand what is or why this model is so important to study. Starting with first. See, each material properties are different, and depending on that property, we use in different application. So, to understand each material structure, composition, and with the help of this structure or with the help of this type of composition, where we can use it in different applications. For that, this module is very important, or to understand this module is very important. Now, what kind of material we can use, or what kind of material we can change according to our application? In this process, we can consider any metal, ceramics, or polymers. Sometimes we can also choose any natural wood or steel. And what are the materials that are completely prohibited to change its basic structure or basic characters? First one, food, water, fossil fuel, and materials whose characteristics must be not going to exist. Now, that means we need to, or we are able to customize the material by adding different types of composition in different proportions, right? And why we can use these kind of proportions or different composition? Because simply to get it used in different application. Sometimes we need more resistivity, or to increase the more resistivity, what kind of composition or what kind of materials we need to use, that depends on us. If we need to increase the conductivity of the material, so what type or what percentage of materials by adding in particular composition, with the help of this composition, how we can increase the conductivity of the material, on what is the level of the conductivity in that material. We can learn. For that, customization is very important. Also, that means these materials are characterized not only by their nature, understand? After this, also by their function, where we can include any biomedical or electronic materials. These are the functional classification. This is why we are studying this entire hour. So, begin with what is nanophase material. If you see the definition of nanophase material, there are two important concepts we need to observe. One is atom, size of the atom, or grain size of the material. Size of the atom or grain size of the material must be under 1 to 100 nm. Then only we can say the material which we are saying are the nanophase material. Otherwise, we can't say that. So, what is a nanophase? For that, we need to take one simple example. As you can see here, let us try to understand what is nanophase with the help of one example. As you can see in this video, we have one gun. Try to concentrate on the thing. Okay, if you see the ray carefully, focus, and if you try to select any one single strand whose thickness is something around 100 micrometer, Okay, that means 10 to the power minus 6. If you are able to zoom it once again, then the cells which we are observing, which is around 10 micrometer in thickness, if you are able to zoom it once again, the material, the cells which we are observing, which is around 1 micrometer. Now we are entering into the nanofield, the size of the things or size of the materials which we are about to say 10 nanometer to 2.8 nanometer. This is the size difference. This is the nano phase material. I hope you understand whatever I try to explain in this video. And if you think or if you understand whatever I try to explain in this video, please consider the subscribe to my channels and don't forget to press the bell icon and share with your friends. So let us see the next process. Here we need to understand the synthesis of nanomaterial. For synthesis of nanomaterial, we have two important types. One is a bottom-up approach, another one is a top-down one. Starting with top-down approach and bottom-up approach. So, what is top-down approach? Simple. We are decreasing the bigger size molecule to smaller size molecule. For that, we can use to reduce its size of the material. So, as we can reduce bulk material to normal material size, normal material to micro material size, and micro material to nano phase material, where grain size of that materials is 1 to 200 nanometer. So, this is what we call it as nano phase material. So, for this, we choose the method called top-down method or top-down approach. Example for this, we have ball milling technique. Second, and why we need to choose these method to prepare a simple nanoscale structuring. Okay, so let us see the second type. Here we can see the bottom-up approach. So when we say bottom-up approach, that means we simply trying to accumulate a nanophase molecule or very small molecules compared to the nanophase molecule and accumulate it and make a complex nanostructure. So by doing this process, by considering this process, we call it as bottom-up approach. Means we are trying to accumulate all smaller particles, and the outcome of that process, we are trying to generate a molecule which is complex nanostructure. And this process we call it as bottom-up approach. Example for this, we have soldier method, or we can say in paper-based depositor. I hope you understand this process. Let us see the classification of nanomaterial. So, in this classification of nanomaterial, starting with zero-dimensional nanomaterial. See, when you see in this image, we have so many molecules. Try to concentrate on one one. As you can see, x-axis, y-axis and z-axis, we all live in the three-dimensional space, and that's why we name it as x-axis, y-axis and z-axis. All the three-dimensional signs, all the three-dimensional space, the size of the molecules, which is very less than nanometer or very less than 100 nanometer. That means we call it as zero-dimensional nanomaterial. Example, quantum dots. In second one, we call it as one-dimensional nanomaterial. That means with the help of dimension, x-axis, is compared to x-axis is very lengthy compared to other two dimensions, y and z. That means y and z comes under nanometer and nano phase. Well, the x-axis is out of the phase. That's why we got it as nanotube. For example, we got it as a carbon nanotube. With the help of carbon, we produced carbon nanotubes. Understand? Now, let us see the third one, which we got it as a two-dimensional nano-phase figure. Now, in this type of design, x-axis and z-axis not under nanophase. Only y-axis is under nanophase. That's why we got as a nano sheet. Example is nano sheet. This is why we got it as a two-dimensional nanomaterial. Last one, we got it as bulb or three-dimensional nanomaterial, whose x-axis, y-axis and z-axis not under nanophase. So, this is the classification of nanomaterial. And as an example point of view, we can expect a 2 marks definition from what is nanophase material, or 3 plus 3 total 6 marks question to explain the synthesis of nanomaterial. Or sometimes we can combine 3 important questions or 3 concepts: definition of nanophase material, classification of nanomaterial, synthesis of nanomaterial, and classification of nanomaterial. Combining all 3 concepts, we can ask it for 10 or 8. I hope you understand whatever I try to explain in this video. Please feel free to subscribe to this channel, share with your friends, and don't forget to press the bell icon so that whenever I try to explain or whenever I try to upload the video, you will get a notification and you are not going to miss any video related to this. With this,